Today's project is a remake of an old favorite where we just blink the LED on and off with a Pi, and yes, it's a very simple project, but we're going to add a graphical interface to that to make it a more advanced project. And let's take a look and see how we did this. The hardware is very simple. It's again just a repeat of what we had done before. Let's start over here at the Pi. We'll look at pin 39. It's a ground. It's the black wire. Comes over here. It connects to this side of our current limiting resistor, which is a standard item when you're hooking an LED directly to the Pi. Goes to the LED. The positive side of the LED goes over here to this red wire. Comes back over here to pin 37 on the Pi, and that's it for the hardware. Not very difficult. I'll put a diagram at the end. So now let's go look at the software and see what really makes this different. This is the software. It's quite a bit of an upgrade from the original blinking LED light. This one has a graphic representation of when the light is on and off. We'll get to that in a second when we run it. But let's go through the code and see what's happening. So first of all, this was written for Python 3. It's written for the Raspberry Pi. It's going to blink an LED that's connected to pin 37, which is going to give out 3.3 volts, and then pin 39, which I'm using for ground. I'm using functions to do this as opposed to just straight code. And we're going to have a graphic indication of what pin 37 is doing, whether it's on or off. I'm using the graphics pack from John Zealous. It's called graphics.py. Did a really good job with that. We're going to import the GPIO because we have to use the pins. We're going to use the time function because I want to use the sleep to have a delay. And then from his graphics package, we're going to import everything. We're going to use GPIO board mode. We're going to set pin 37 as an output. We're going to have 35 iterations. It's on-off cycles of the LED. We're going to wait 0.7 seconds in between each one. Scroll down. The first function is just simply to blink the LED on and off. I'm going to pass it parameters called on-off, X and Y. And this is a little bit strange. The code is not perfect. It's not as beautiful as I would like, but it's okay. So the first thing we're going to do is we're going to take pin 37, and depending on what we passed it, we're either going to turn it on or off. Then if it's on, if it is on, in other words, on-off is true, so it's 1 or true. Message text is going to be pin 37 equals true, and we're going to turn the color blue. So we're going to make the graphic representation blue when it's on. Otherwise, pin 37 is going to be false. We're going to send out that text message. We're going to set the indicator to red, and then we're going to call the graphic out, and the graphic out is what's going to produce our graphic output. Let's go down so we can see the whole thing. So this is our graphic output. This is what's going to write to the window that we create. We're going to have the message text, the color of the dot, and then the X and Y coordinates. So the first thing, this is kind of convoluted way of doing things, but it's the only way to really get a good graphic representation on a Pi. First we're going to erase a space, and then we're going to write to that space. We're going to write the message to it, and then we're going to do the little graphic circle. Okay, so these first things that are called erase, that's exactly what we're doing. We're going to erase the space where we're going to write to. So we're going to erase a rectangle, and we're going to have a rectangle that this is the left lower point and this is the upper right point. And what we're going to do is we're going to set that to gray, and that's the background color also. And we're going to make the outline of that rectangle also gray. So in other words, this rectangle is going to be invisible. We're going to create a rectangle that's exactly the same color as the background. And then we're going to draw that out to the window. Next, we're going to take the message that was passed to us, and we're going to place it at the X plus 80 and Y coordinates. And the reason I did X plus 80 is because I'm going to put the circle, the little indicator dot, in front of the text. So I need some space, so I gave myself 80 pixels. Message, I'm going to set the text size to 10, the font to 10. Then this message, the text color is going to be black. Now this can be many different colors, but chose black. And then I'm going to draw the message to the window. And then the last thing is my little graphic indicator. I'm going to use a circle, and it's going to be at point X, Y, and the size is 5. I'm going to fill the color of the circle with the color that we passed it up here, and then I'm going to draw that to the window. This white plus equals 0, that is going to cause it to be at the same location. Now if I set it to say plus equal 15, it would increment one line, but I don't want to do that. I want it to write exactly in the same place that it always has been writing. Now down to the real meat of the program, if you will, to the main part of the program. This creates the graphic window, so it's going to have a title of RPI GPIO status pin 37. It's going to be this size, 200 by 100. We're going to set the background at gray 95, so that again we can do the erasure. We use all the same color. And the main part of the program, the original X coordinate and Y coordinate will be 10 and 5, and then the X2 coordinate, which is the upper right corner of the rectangle, will be 0, and Y2 is minus 5. Then we're going to loop, and we're just going to do this because otherwise it'd be kind of dull just to turn the LED on and leave it on. We're going to blink it on and off. So the first thing we're going to do is turn it on. We're going to wait our time, which I think is 0.7 seconds. We're going to turn it off, wait 0.7 seconds, then we're going to loop through this, and I believe I set it to 35 times. When it's done with the loop, it's going to drop through. It's going to do the GPIO cleanup, which resets the pins. We'll do a win get mouse, which will wait. The window will stay open and wait until we click into it. When we click into it, it will close the window, and then we'll print done, and then we'll get a done message. The next thing to do is run it and see what happens. Here's our LED indicator down here, and let's hit the run button. And here's our window way over here. Let me move it. So you can see that it's indicating red is off and blue is on. Don't know why I chose those colors, but that's what I did. So you can see it says blue is true and red is false. So blue is on, red is off. Blue is on, red is off. Of course you can do that any color you want. And once it runs through here 35 times, which will take about 20 seconds or so. Okay, it's finished, and now it's waiting for us to click in the window. We click in the window, and then we get an indication that the program finished normally and that it did all of the GPIO cleanup and all that we told it to do down here. Okay, well that's our updated version of Blinky, the graphics version. I hope you found it useful and interesting in your Raspberry Pi programming.